Hello, everybody. Welcome to your free GMAT prep hour. It is January 12th, 2021. My name is Reed Arnold. I will be your host tonight through the wonderful world of the GMAT. If you are looking for other free prep options, we have some for you. You can take the first class of any of our 9-week courses for free. That is 1/9 of our entire class package. No cost to you. Check it out. Do some Google searching. Find an instructor starting a class soon. See which of our instructors you feel like you might vibe with, sign up and see what it's like. I always tell people in these sessions that the first class we cover some of the most important things you would study for the GMAT, and so there's really no reason not to take a free class. We talk about data sufficiency, lay out some of the major strategies there. We talk about sentence correction, lay out some major strategies there. And we talk about what the heck this test even is and how it works, and give you a really good foundational understanding of what the heck the GMAT even does or is trying to do, which will help you frame how you study for this test. Okay. So tonight's lesson, tonight's free GMAT prep hour, we are talking about problem-solving strategies. This is going to be a little bit of a broader free GMAT prep hour than some other ones, but this is something I've been mulling over for a time now. I want to talk about problem-solving, the methods, the tools that are available to get someone through a problem-solving question in quant on the GMAT. There are two kinds of quant questions. Those of you that have studied already know this, but if you're new to the test, there's problem-solving, which is kind of exactly what you think when you think standardized test math. And then there's data sufficiency, which we have plenty of videos out there for that as well, if that question type is tying you up. That is a very GMAT-specific question type. And so we're not going to talk about that tonight. We're going to talk about the problem-solving questions, where it's just a question and you're trying to answer it. Pretty straightforward game there. Okay. And the thing I've kind of been mulling over is that there's not an infinite amount of ways to get through a problem-solving question. It's a pretty finite list, actually, for what you can do to answer a question in a problem-solving setting. Okay. And so today I've just been kind of brainstorming what are the most common strategies that one could use. And this is kind of the list I've made. Now, others is obviously kind of cheap. That's my fail-safe for like, I might have missed one here. Here's the others category in case there's something I don't think about. I'll be curious at the end of the session, actually, if we discover one or if there's an approach you all think like, no, that should definitely be on the list. But there's really not that. There's a finite ways to get through a problem-solving question, and I wanted us tonight to kind of explicitly lay them out and explicitly think about them and use them to work through different problem-solving questions. Now, like logical reasoning is kind of, well, you're always logical reasoning, so that's that kind of pervades all the rest of the test and all of these strategies. So that's a little bit broad as well. And certainly things like tables and charts, certain question types have a certain chart that works for them. So it's not like there's one table that fixes everything. It's not like there's one picture that you can use for multiple questions. The context of a question tells you what picture to make. The content of a question tells you what table or chart to use. And so you can certainly build a certain stimulus response for, okay, for this kind of question, use this table. For this kind of question, use this chart, what have you. For like plug and chug, that's something that's done often, for instance, in function questions, function and like weird symbol questions. There are others where you can do it, but that's a good sign that you might use the plug and chug method. So certain strategies are used more with certain question types and in certain topics, but I kind of just tried to, here they are, algebra, picking smart numbers, back solving, estimation, logical reasoning, testing cases, which is usually used in data sufficiency, but does show up in problem solving as well. A lot of times, in fact, for convenience, we kind of call testing cases smart numbers, but I'm being very pedantic in separating the two strategies. You can make a table or chart as to organize the info. You can draw a picture or a number line or a set of numbers, or I should have put a shape. You can put a shape on your page, right? That's like visualize the thing you're dealing with. You can do a plug and chug, crank out the situation kind of inelegantly, but sometimes it's a good way to do it. You can look for a pattern sometimes, especially if you are plug and chugging, okay? And the other thing about this that I realized, and I realized this like literally an hour and a half ago, I have a theory that good test takers almost always use two strategies at once. even if they don't necessarily know it. Most people, and this is another point I want to make here, a lot of people gravitate way too much to algebra. If you've watched our videos before, you've probably heard us say that. And then we have some teachers at Manhattan Prep who are like borderline anti-algebra. They are, I don't do algebra, I don't teach algebra. If I'm taking the test, I try to do anything but algebra. And I am a little bit less rabid about that. I think algebra is a good tool, but I want to emphasize and make sure it's clear that we know that it is just one of many tools. I hesitated even putting it first. The only reason I didn't put it first was because I felt like it would be one of the obvious teacher things to do, to put it like last, as if to make a point that it goes last. I don't know. So I put it first because I know it's the first one people think about. But it is just one tool of others. And when people use algebra, when someone who's good at this test uses algebra, there's usually something else at play. Often they will draw a picture or a set of numbers of some kind, or something to visualize the situation, a shape if it's geometry, right? They will do that in order to correctly set up the algebra, because a lot of times setting up the algebra is the hardest part. A lot of times people will start with algebra and then they'll realize back solving is a much more efficient way of getting through the question. People test cases. It's often helpful to use a table or chart to organize that information. Back solving, it's often helpful to use a table or chart to organize that information. I really realize that most of the time I am doing at least two of these things at once. And so I just want us thinking about that today as we work through these problem-solving questions and review these problem-solving questions and find, okay, which strategies do we use for this one? Which strategies could we use for this one? Which strategies can't we use for this one? And quite frankly, what I kind of want you to start doing when you study is have this list of 10, and if you feel like you want to add others into that number 11, I think that's fine. But a good way to review a question is literally just run through the list. How well can I do algebra here? Can I do algebra? How can I do algebra here? Can I use smart numbers here? Why or why not? What smart numbers would I do? Can I back solve? Can I estimate? Can I use logical reasoning? Can I test case? And just, if you're wondering how to get through a question, just get used to thinking about these different strategies, because almost all test questions will fit one of these strategies, especially the broad others category. But again, I tried to really lay out the most common ones up front. And the other thing I want to think about, want you to think about today and moving forward as you study, is identifying where the difficulty is in a problem-solving question. Okay. A problem-solving question, again, it's straightforward. There's a question where they give us some information and they ask a problem. They ask a question here. Okay. You will go from that question into a strategy, and then you will hopefully go from that strategy to an answer. Okay, and you'll pick a strategy, or maybe perhaps some combination of strategies as part of that, and then you will actually work on those strategies to get to the answer you think is correct. And I think that there are a few steps of difficulty here, right? First, which strategies could work? Identifying which strategies could work is kind of step one. And that's not an easy question a lot of the time. Okay. Or which strategies are most efficient of those, right? Once you've identified a few that work, which are most efficient? And it's not, sometimes there's a tie, sometimes two are equally efficient, but that's something you would ask yourself. Okay. And then there's the difficulty of actually using the strategy, right? Actually using the strategy to solve. Well, first off, not even that, actually doing the strategy. For instance, I could tell you, I could pick a question right now and tell you back solving is the best way to do this question. And it's still a hard question, right? You know it's back solving, you know back solving theoretically works, but to actually do back solving is difficult. I could tell you, like, you should draw a picture on this question, but okay, what picture do I draw? Why is this the picture that is drawn, right? So once you've picked a strategy, then there's a difficulty of actually doing the strategy. And maybe even just like starting the strategy, let's say starting the strategy, even knowing where to begin. Then there's finishing the strategy to the answer. right? That's kind of two things. They're starting the strategy and then actually going through to the answer. Okay, and all of these moments in the problem-solving process have the chance to be mind-bogglingly difficult, depending on the, and sometimes some questions, all of them are hard. Sometimes the first two are easy, and then the third is hard. Sometimes the first three are easy, and the fourth is a nightmare, right? Like there's a lot of variety here. But when reviewing a problem-solving question, it's really worth asking, like, where is the most difficulty? Is it hardest to just figure out what strategies could work? Is it hardest to pick one that is most efficient? Is it hard to even start a strategy? Like, where is the difficulty and why is that the difficulty? Okay, and again, good test takers often combine these. They'll do two or more at once. I'm realizing right now, for instance, that I probably could add rephrasing to this somewhere. Rephrasing is, again, a strategy that is most often used in data sufficiency. But there are certainly problem-solving questions where rephrasing is a valid strategy. You wrestle with the question itself until you realize what's really being asked. Now, again, it's usually involves, you usually rephrase by doing logical reasoning or by working through some algebra, whatever it is. Like there's often a combination of strategies at play, but I am realizing that that would probably be a good addition to this list. Okay, so let's just get to work here. We're just going to do problem-solving questions. I'm going to keep this list up, and I just want you to work through the question and maybe put a little bit of a heightened awareness on what strategies you're actually using to get through this problem. So I'll give you all about 2 minutes here. When you have an answer, go ahead and type it in the chat. It's about 2:20. Yeah, and if it's a guess, feel free to put a question mark. That's fine. But do get in the habit of choosing a letter, even if you're not sure. It's just a good habit to get into. You have to on the test. They make you. And it's good to get used to being like, well, chose the wrong letter. Oh, well. Okay, so it looks like we're pretty hodgepodge here. We got quite a few answers coming in. We got some D's, some A's, some B's, some C's. some A's, I think. Yeah, we're pretty spread out on this one. Not a lot of consensus coming through in the chat. Yeah, hard to say that anything is winning here. So, okay, I'm curious, which of these strategies, and if you have another one, I'm happy to hear it. But I would say that there's definitely some of these strategies one could use here to help get through this problem. So Tob says, find a pattern, plug and chug. Tob, how did you plug and chug? Jaydeep says, using a table. I have diagramming, testing cases, choosing numbers, cases. Hannah did algebra. Okay. I'm curious how the algebra was done. I'm sure it's possible. I actually didn't think of doing algebra on this question. One of you, Hannah or Paige, that did algebra, can you type how you algebraically solve this one? It might be a long typing situation. I don't want to make you type till your hands fall off. Deepak, we'll get to the right answer. Fear not. Answers are so dull. Process is what matters. So I would say, and if someone did algebra and wants to type in the chat how they did it, I'm happy. I'd love to see it because I'm very curious. I would say, first off, the first place I would go to solve this question would be to set up a table or chart of some kind. And there's no one right way to do this, but I'm thinking that, okay, we have 3 teams, 3 members each. So I guess you could say there's 9 racers in 3 teams. If you want to just organize your givens, that's certainly a good strategy. A team earned 6 minus n points whenever one of its players finished in nth place. And this is the sentence that I would say is one of the, and there's some subjectivity here, but I'd say that's kind of the sticky point on this question, or one of the sticky points. What does that mean? A team earned 6 minus n points when one of its members finished in nth place. And so this is kind of a, you could also argue that I'm finding a pattern and plugging and chugging here, but it's like, well, what happens at first place? I know someone wins points. Well, if it's first place, so n is 1, right? Because that's nth place. So that's n minus 1, or I'm sorry, 6 minus n, 5 points. So first place gets 5 points. Second's going to get 5 minus 1, so 4 points. And now I notice a pattern. Third gets 3 points. Fourth gets 2 points. And fifth gets 1 point. Fifth, that's not how you spell fifth at all. 1 point. And then all the rest, none. None for Gretchen Wieners. What's that from? I don't even know what I just referenced. Mean Girls, that's what that's from. Good, so we have this situation going on. And so I've kind of set up a chart. It's a loose chart, but that's, I mentioned at one point in my incoherent rambling, I said something to the effect of people do multiple strategies even when they don't know they're doing multiple strategies. It's actually a lot of people who are good at this test, they organize their work into a table, even if they don't even think, I'm making a table right now. They just know that that kind of grid organization is going to serve them. And I think that's kind of what's happened here, right? I have these 5 places. Okay, they each get this amount of points. And now there were no ties, disqualifications, or withdrawals. If no team earned more than 6 points, what is the least possible score a team could have earned? Well, now since I'm talking about least possible, possibility is often about testing cases. Just in general. I mean, testing cases is really about what is possible under constraints. Okay. And so now I'm in a world where I am considering what cases could be the case in this situation, where the constraint is these are the points and no team earned more than 6 points. Okay. And so it's like, well, let's put some team won first place. Let's give that to A, team A. And now I use some logical reasoning to see that, you know what, if team A got first place, they didn't get second, third, or fourth, because that's more than 6 points. So really the only other outcome for team A is either they didn't get anything else or they got fifth. Maybe they got fifth. Okay. And then team 2, another team, whoever it is, team B, got second place. And then I just use the same logical reasoning to say, well, team B didn't get third place because that's 7 points. That's too many points. But maybe they got fourth place and they had 6 points as well. And then maybe C got third. And in that case, C has the fewest points at 3. Okay. And that alone, maybe the answer is 3. The question is, can we know 4 is out. Can a team get 2, 1, or 0? And you might try to test another case here. You might try to say, okay, let's make C only gets 2 points now. Okay. So, and that's the only points they're going to get because we're trying to get less than 3. Well, you're going to struggle on this because if you, team A, either team A or B is going to get first. And then since we don't want to give C any more points, team A or B has got to get second, but we can't give A any of these. So let's make B again here. Well, but hold up. B can't be third and A can't be third. So I guess C is third, but now C has 5 points and we're too big. And so what we're going to realize is, nope, the answer's got to be D. The least amount of points a team could get is 3. Okay. And so this is testing cases in a table or chart with some logical reasoning and perhaps finding a pattern there to help generate the chart. Okay, so we end up using several different strategies here. I'd say 2 big ones, testing cases under a table and chart, but we are using these strategies to solve. Okay. So again, if you struggled with this question, you would have this list near your desk, have this list somewhere, and run through the possibilities and just really see. And then when you read the explanation, right? When you read the explanation, fit it into one of these categories, because these are the tools that someone has. JD asks, how were you so sure the 4th place was team B and not team C? In this first case, JD, if I assume that's what you mean, I don't know that this is the order. That's not the question. In fact, it could have been like this second case is just as possible. The difference is that I want the least amount of points for the losing team. And this second case has more points for the losing team. Well, actually, I guess in this case, B is the losing team, but B has 4 points, which is still more than 3. Here, C is the losing team with 3, and any other case is going to have more than 3 points for the losing team. So Maddie asks, yeah, what if team C was the worst and team C got 6th, 7th, and 8th and no one lost? The problem is, Maddie, that means someone else, that means that these 3 racers from team C are out. And that means 1st through 5th were all A's and B's. And here's the problem. If I do that, if team A got 1st place, they can't get anything but 5th. Because if they get 1st, 3rd, and 5th, it breaks this constraint that no team, and I'd probably want to write that down, right? No team more than 6 points. And if A got 1st, they can only get 6th, because if they get 3rd or 5th, or so 3rd or 4th or 2nd, they're going to break the 6-point ceiling. And then, okay, so let's make that A, but let's put the rest at B. Well, but then B gets more than 6 points, and that's not allowed. So this case just breaks the rule. A team can't get no points. Not because of the rules of the game, but because of this constraint we are given, right? In the race in real life, yeah, someone can get 6th, 7th, and 8th and get no points. But when we are told that no team earned more than 6 points, different scenario. Okay, we move on there. But again, the point is what strategies are available, which ones do I use, and what about this problem makes me use it, okay? This is a situation where I have, 5 different places, 5 different categories. That kind of thing makes me think of the slot and blank method, or there's a few different names for it, but just like here are the places for first, second, third, fourth, and fifth. And then I just specify how many points they get, 5, 4, 3, 2, 1. And I might write, points for place. It's just a different version of the table, but same idea. And then I start, okay, labeling the A's, B's, and C's. Okay, let's try this one here. That's about 2 minutes. All right, so that's about 250. Most answers coming in. C has a little bit of gravity, but there is some variety out there. I think C has the majority, looks like 3/4, about 4/5 are choosing C. So what strategies do we use and why? JD says some estimation was used, visualize. Yeah, I would say this one is quite clearly a visualization. Anytime there's a shape involved, you're going to want to put it on your paper. Visualize the thing. We have a circular track around the edge of a lake that has a diameter of 2 miles. So we have a 2-mile diameter. And we know Johanna walked once around the track. So here's Johanna at 3 miles per hour. And she went once around the thing. And her time was T. Okay. I'm getting an alert that says I am muted. Am I muted? Can you all hear me? No one is saying I can't hear you, so I'm assuming, okay, good, so people can hear me, all right. Something was glitchy with Zoom. Okay. I suppose you could call this algebra. I guess it's a geometric formula, and I don't know if I had a list. I don't know if a point in the list should be set for like formulas, but circumference equals diameter times pi. That's just a formula to memorize. And so the circumference of this track is about, or is approximately, because I guess technically the track is around the lake with this radius, but the circumference is about 2 pi. The diameter is 2 pi and circumference is diameter times pi. That is the circumference. And in this case, that is her distance. And so when we're dealing with distance, rate, and time, I like to draw my distance, rate, and time equation. And I almost always, again, this is one of those times where I realized I pretty much always do this in a table, even though I'm not aware that I'm doing it in a table. But I just like to think of it as the slots of a table seems to help me get through the math. And so I know the distance that Johanna went was 2 pi. And I know her rate, I'm told, was 3. And I'm solving for her time. I have a question, will they give us a basic equation sheet? No, they do not. You are expected to memorize the fundamental rules and formulas for the test, including, for instance, the formula for circumference. There are some they don't expect you to know, like if they ever ask a question about the volume of a sphere or something like that, I'm quite sure that they would give you that. But most other formulas will need to be memorized. Okay, and I want to know the range of t. Now, here's the hitch, right? I know that, and I should use maybe a lowercase t since that's how it's represented. The time is t. I know that t equals 2 pi over 3, distance over rate. But that's not an answer. And so this is when I can do what some other people are discussing, which is like, hey, we can estimate that part. Okay, we don't need to solve for t. We don't need to be precise on what t is. We can estimate. Pi is a little bit more than 3. It's a little bit greater than 3. So 2 pi over 3 is going to be a little bit greater than 2/3 of 3, which is going to be a little bit greater than 2. And so I would choose C. 2 is less than t is less than 2.5. Okay. If you like, there are some other things you can do. Like some people estimate pi as, oh gosh, what is it? 11 over 7, I think is. Let me double. No, not 11 over 7. 23 sevenths. I'm trying to remember what the 22 sevenths. 22 sevenths. Yeah. See that? I mean, that's I hardly ever use that. But you could say it's 2/3 of 22 sevenths. But I don't know if that's in it. I mean, it's easier to just be like, I don't know, it's a little more than 3, and 2/3 of a little more than 3 is a little bit more than 2. And yeah, you can always estimate it's 3.14 if you're okay with decimals. This is a handy fraction estimation. But I would say this one here, we're using a visualization just to get the situation down. I guess we're using a little bit of algebra to solve for circumference, if you can call that algebra. And then we're using some estimate, and I guess solving for t is that is algebra, right? Dividing the distance by the rate to solve for t. But the last step is pure estimation. Kayla, we do not get a calculator for the main quant section. That's why estimating is a good tool to have. Okay. And so if you miss that question or you struggled with that question, I want you to think about what tactics, and again, there might be other ways to do this question. And when you're studying at home, you want to find multiple ways, and we'll probably have time to do a question where we do find multiple ways. But when you're studying an approach or studying a solution path, you want to figure out where the difficulty is. Was the difficulty in seeing that that was the solution path at all? Like even knowing that, hey, that's a path I can walk. Okay, what do you need to do to realize this is a path you can walk? Right? Do you need to know your circumference formula better? Do you need to think, oh, geometry, draw the shape, draw the picture? For distance, rate, and time, is it helpful to you to put it in kind of chart formation? What signs are there that we can estimate? The best sign is that we're not actually asked for the value of t. We're asked for a range of possibilities. And for a range of possibilities, if you're roughly in the range, you're going to be good to go. So that's a good sign to estimate. You can tuck that away, tuck that knowledge away. Oh, answer choices that don't ask for specific values, but instead for a range might be solved by estimating. Not every time, but often. So that's if you didn't know what the paths were. And then it's like, okay, I knew to draw a picture, I knew to estimate, but I couldn't see how to do it. Okay, where was the sticking point there? Try to figure out where things get stuck. Okay. Let's take a look at this. So the questions we've done so far, by the way, have been from the official GMAT practice tests. This one right here is one that I made up, but I think it's a GMAT-like enough question to, I've seen questions similar to it. So take 2 minutes to work through this problem here. So that's about 2.5 minutes. I'm doing my own problem and wondering if I made a mistake setting it up, putting the answer choices down. If anyone's getting an answer choice that's not there, you might not be alone. The answer I'm getting at the moment is 40. We'll see if we can catch where my mistake was either in this work that I redid or in the work that I originally set up. I'll be curious to see. And plus 3 is 12, 14, 22, 29, 35, 40. I thought I had meant the answer for the record to be 39. That's what I had the first time when I actually set up the question and double checked it. So that's weird. But now that I'm doing it again, I got 40. That's okay. Who cares about answers? The point of the day is process. So what strategies did we use? What strategies do we have for this question here? Chart and plug and chug. Yeah, good. List of perfect square, right? So we're a list of numbers, right? What numbers do we care about here? We have a set of numbers, a list of numbers. You can put it into a chart if you want. Okay. So yeah, the set of numbers of perfect squares. What set of numbers, what is that set of numbers? So go ahead and type out what that set of numbers would be, or what numbers would be on that set of numbers. Let's generate the set as a group, 1 to 9. Why would that be the set of numbers 1 to 9? I might be misunderstanding something. 1, 2, 3, 4, 5, 6, 7, 8, 9. Why is that the set of numbers we care about? Because those are, okay, we then square those. 1, 4, 9, 16, 25, 36, 49, 64, and 81. Yeah, 10 squared is too big. So once we have 10 squared, we're already more than 100, and that's not going to work. So we want perfect squares that we're adding together, and we want the sum to be less than 100. So let's get the perfect squares. Okay, let's just, and this is kind of a plug and chug situation. It's just like, let's just list them out. I don't know. Let's see what happens. But I will say that we are ignoring a friend that we could use. And that's one reason why that's a big trap for this problem. What number might we be missing that we could include on this list? Yeah, we actually can include 0. And I see some people in the chat saying, hold up, the question says positive. What does positive describe? The sum. Positive describes the outcome of the adding of the two perfect squares. It doesn't say the perfect squares are positive. It says the outcome of the addition is positive. This is a big GMAT thing, by the way, specifying what category, what constraint fits what part. The sum is constrained to positive. The perfect squares are not constrained to positive. So 0 needs to be included on this list. And now it becomes a game of, okay, how can I add these things together? How can I add these together? Well, I can add 0 to 1, I can add 0 to 4, I can add 0 to any of these numbers. It does specify these have to be different, so I can't add 0 plus 0, and also that wouldn't be positive, but I can add 0 to 1, 4, 9, 16, 25, 36, 49, 64, or 81. That's 9 options right there. Okay. It's not 10 because I don't want to include 0 itself. I want to think about the 9 other numbers I can add to 0. And then I can do 1 And it's kind of the same game. I can add 1, 2, 4, 9, 16, 25, 36, 49, 64, 81. I don't want to count 0 again. I've already added it to 0. So I can do these 8 choices. Well, then I can do 4. And I can add it to all the other problems here, all the other numbers. And like I kind of am starting to notice a pattern, right? 9, 8. I think this is going to be 7. And I don't need to know the sum. I don't need to say, okay, 1 plus 4 is 5, 1 plus 9 is 10, 1 plus 16 is 17. I'm just wondering how many possibilities there are. So 1 to 81, I can add 1 to 81. I'm still less than 100, so I'm good to go. 4 to 81, 4 plus 81 is less than 100. 9 to 81, 9 plus 81 is 90. That's less than 100, so I get 6 options there. 16 to 81, let's reverse the course just for organization. That gives me 5 options. So I have a question, why not include 0 when I did 1? Because I've already added 0 and 1. When I started with 0, I just added it to 1, 4, 9. I counted that already. I've included 0 plus 1. I don't want to include 1 plus 0. That's the same number. 16 has 5 options. 25, and this is where things get tricky. You might say, oh, a pattern has started. And I know we like patterns. And a lot of times you want to find patterns. But in 9, 8, 7, 6, 5, 25 can't go all the way to 81, I'm afraid. Because 25 plus 81 breaks 100. 25 can go to 64, so that gives me 3 options. 36 can't go to 64. That gives me 2 options. I think that's it. So 5 plus 3 plus 2 is 5. Plus 8 plus 7 is 15. Plus 9 plus 6 is 15 is 40. Kate asks, can't you add each number to itself? No, because it says the sum of 2 different positive integers. So it should have been 40. Unless someone sees a mistake in my work, I think the answer is 40. Happy to be proven wrong. Doesn't 36 and 40. Oh. Huh. That might be it. Yeah, I think that's it. Thank you. Gosh, I knew something was crazy here. 36 and 49, that's 2 numbers, but it's only 1 sum. Thank you. Goodness, I was right originally. Oh, I knew something was wonky here. It is 39. Gosh, is that what I did? Am I that silly? It is exactly what I did. That is exactly what I did. Yep, 36 plus 49 is 2 numbers, but 1 sum. So the answer is indeed 39. Thank you. Good catch, whoever caught that. Hella, what would it be if it didn't specify different? Well, we would have to include then 0 plus 0, 1 plus 1, 2 plus 2, 3 plus 3, 4 plus 4. Oh, no, sorry, not 2 plus 2 and not 3 plus 3. 0, 1 plus 1, 4 plus 4, 9 plus 9, 16 plus 16, 25 plus 25, 36 plus 36, and 49 plus 49. The others are going to be too big. So that would be 1, 2, 3, 4, 5, 6, 7, 8 more that you would add. So that would be 47. I probably should have included that as a trap answer. 0 is not considered a positive integer, everybody. Careful here. I'm not saying 0 is positive. The positive integer, the thing that has to be positive is the sum of the 2 numbers. So 0 plus 2 or 0 plus 4, for instance, is 4. 4 can be written as the sum of 2 perfect squares. 0, 0 squared plus 2 squared equals 4. So these 2 perfect squares give me a positive integer. Okay. I could also say 0 squared plus -2 squared. It's true that I could square -2. Some people are asking about negative squares, but that's still one number less than 100. Again, the thing that matters ultimately, the thing I'm counting is the sum, that last number, not how many inputs we have, how many outputs there are. 0 is considered a perfect square, always, yes. 5 plus 5 plus 15 plus 15, that was the sum of these numbers. Also, it's wrong. It should be 5 plus 3 plus 1 plus 9 plus 8 plus 7 plus 6. I was trying to be fancy earlier, but it didn't work out. That was silly. Someone else asked earlier, why can't I do 10 choose 2 or something to that effect? Because it's like, hey, there are 10 perfect squares. Why can't, and I'm picking 2 of them, why can't I do 10 choose 2? Because some of the 2 that you would pick, for instance, if I pick 64 and 81, the sum is more than 100. So I can't just pick 2 of these at random. I need a sum less than 100. This is a very much a plug and chug problem. There are 10 choose 2 total sums of these perfect squares, but too many of them are more than 100. You could do 10 choose 2 minus the number of cases that break 100, but I mean, yeah, that's fine. That's probably a little bit faster if you're really good at 10 choose 2. 64 plus 81, 49 plus 81, 36 plus 81, 25 plus 81. That's 5. 64 plus 49, 64 plus 36. Yeah, you could do that. Yeah, the 6 cases that are more than 100, that's doable. Sure. Yeah, that's probably a little bit faster. I like that. Nice thought, Deepak. So that's a little bit less elegant. That's a little bit more elegant than my plug and chug method. I guess you could, that would be bringing in some logical reasoning to realize, oh, well, I could either count up the sums less than 100, or I can get all the sums and subtract the ones more than 100. Okay, we're gonna move on from this one because I don't want to spend too much time here, but this is just a good example of list your set, list your numbers, plug and chug, quite frankly, and fit the parameters. Just make sure you fit the parameters. Let's do a question or 2 more, and then we'll wrap up. And again, I will stick around for any other miscellaneous topics you all want to discuss. Let's do. Yeah, let's do this one here. 2 minutes. About 2 minutes. Okay, for the sake of time, I'm going to call it there because actually there's one more question I think I want to do just to drive all this point home. So I see a lot of those who are answering, C has the plurality, it looks like, but I'm not seeing too many answers come in. So it seems like this is probably and this is a harder question. Someone said, JD says, I used pure algebra on this one. Unfortunately, I mean, again, I don't hate algebra. I just think it's one tool and you would want to develop other tools. But if it works for you, that's great. I guess my question is, what did pure algebra look like to you here? Because there are a few ways to do pure algebra even. What was the pure algebra you did? Nice, JD. Yeah, so JD used a concept called the unknown multiplier in the algebra, which I think is the key idea, right? If we have K and Alberto, originally they had a 5-to-3 ratio. And then we had the 10 stamp swap. And the new ratio was 7-to-5. And again, this, I might draw, this is kind of a picture, I guess, like I might draw this to really make sure I understand the situation before I start setting up the algebra, before I start doing the algebra. A lot of times I draw a picture, I make a chart, I make a table, something to help me understand the situation before I try to build an equation from the situation. And so I know that originally K had 5x stamps and Alberto had 3x stamps. That's using what's called the unknown multiplier, because I have this, because I know how ratios work, right? This is the relative amount. These are the actual amounts. And then I know that K lost 10 stamps and Alberto gained 10 stamps. And that gave us a new ratio of 7-to-5. So yeah, there is a straightforward way to do algebra. That's why I included this one, to show that, like, yeah, you can do algebra sometimes. You can cross multiply here, get that 25x minus 50 equals 49x plus 70. Trying to determine if I've set this upright first. 25x minus 50. Oh yeah, 7x. I don't know why I said 7x, 3x plus 10. Something seemed wrong. So yeah, thank you, 21x. $21x plus 70. Subtract the 21x to get 4x, add the 50 to get 120. X is going to equal 30. So that tells me that originally it was a 150 to 90 situation, and then it was a 140 to 100 situation because there was a swap of 10, and so K has 40 more stamps than Alberto. Notice this devious trap answer of 30. If you solve for X and you're like, 30, I did it, 30. That's not the question. Be careful. Make sure you answer the question. And I'm being a little bit lackadaisical about it tonight because it's not the purpose of this drill, but I should be more diligent. And, I would write down my givens and write down my ask, right? K has how many more than Alberto? So this is a great way to do this. I don't want to decry algebra at all on this problem. I think it's a good way to do it. It's probably how I would do it, but it's not the only choice you have for this problem. You could use back solving. It requires a good understanding of how ratios work, but if you know that k to a at the end is 7 to 2, I'm sorry, 7 to 5, then you know that difference is 2, like 2 units in the ratio. And we can then plug and chug answers or back solve our answers with that 2, right? Because this 2 represents how many more stamps K has than Alberto. Let's start with D. If we say that K has 60 more stamps, that means that 2 to 60, that would be a multiplier of 30. So it would be 150 and 210. That would mean the original K and the original A before K, so this is after K gave the stamp. She used to have 220, and Alberto used to have 140. And what's the question I ask about 220 and 140 right now? Is this a 5 to 3 ratio? Very good, JD and Deepak, yeah. Is this a 5 to 3 ratio? No, it is not 5 to 3. Because that's what I'm told. I'm told it was originally 5 to 3. And so this is not an answer choice. This is not correct. This is, what would this be? 22 to 14, 11, this is 11 to 7, which seems to be a little bit more than 5 to 3. I don't know. It's too late to gauge that. Too tired. But what we can do is we can then test, okay, well, what if it was 30? Let's say K to A was 30. Well, that means that the multiplier is now 15. And so that would be 75 and 105. Same idea. Okay, K used to have 10 more. Used to have less. I feel like I've done something wrong here. Double check my math. 2 times 15 is 30. Times 15. 5 times 15 is 75. 7 times 15 is 105. Yeah, everything looks good. Is this 5 to 3? No, it's not. It's 23 to 13. Okay. Seems like we've gone too far. That's a little bit tough for me to gauge right now. I might just plug and chug. Say 40, which would be then 100 and 140, which before would be 150 and 90, and that is 3 to 5. Yeah, Deepak, that's what I'm having. My brain's a little foggy right now. I'm having a hard time noting which way we've gone. It seems like we've more than doubled our 11 and we've less than doubled our 7. So it seems like we've gone from, I'd have to know where 5 to 3 falls in relation to these, and it's pretty tough. These ratios are not nice and easy to compare to 5 to 3, unfortunately, so it's hard to know which way to go. Someone who was sharper than I am could figure it out. I'm sure there's some people with much faster quant minds than I have at the moment that could figure out, well, 11 to 7 and 23 to 13, you've gone too far in the numerator's direction, so that means you got to go back. I don't know. That's tough. Once you've laid out the process, though, notice there's a table or chart I'm using. Back solving and tables and charts are really good friends. You should look out for that. Makes it much easier to work through the thing, because now it's just literally you're plugging and chugging in a table while back solving. Okay. Let's do one more, because I think this is a good reminder of some other strategies as well, some we haven't seen tonight. take 2 minutes here. Change one phrasing here. All right, that's about 2 minutes. For the sake of time, I'm going to wrap this one up. If you are watching a recording, feel free to pause and keep working. This is a good chance to use smart numbers, and it's a good chance to estimate. And I'm going to use a table to organize. Okay. How do I know smart numbers? Well, everything is a percent. It's all relative. And whenever that's the situation, it's almost certain that I can pick smart numbers. How do I know I can estimate? Because it says approximately. Oh, also, I meant to give you, I meant to, well, shoot. I had a typo in one of the versions of this problem. I made it 79% as long. It doesn't change much. It was just a chance, just to like, we can estimate through this problem. Okay. We have here the editor's short version, the editor long version, the director's cut, and the studio cut. And we have to pick some values for them. We're told that the editor had 2 cuts. The shorter was 25% shorter than the longer, a large amount of time. So let's call the long cut 100 minutes, and the short cut was 25% shorter. So it's 75% as long. We're told the director took the longer version of this cut and added a scene back so that it was a 10% more. 10% longer. And then we're told the studio, this was 80, but I meant to put it as 79 to really emphasize the estimation part here. Because it's like, well, 79% of long is basically 80% of long. 80% is long, and 4/5 of 110, it's like, it's about 90. I think it's exactly 88. So you could say the studio cuts was 88 minutes long. And then the question is, okay, which of the following expresses the relationship of the editor's shorter cut to the studio cut? So we're comparing 75 to 88 at this point. Well, we know it's not the same length. We know the studio cut is not shorter than the editor's cut. So it's either 10% longer or 15% longer. Well, 10% longer than 75 is about 7.5. And that's about 82 minutes, and that's not near long enough to be 88 minutes. So it is probably The studio cut is 15% longer than the editor's shorter cut. Okay. 13/75. That's the 13-minute difference from the editor's shorter cut to the studio cut. You could say that's about, what's a multiple of 75 near this? 50, 26, 52, 65, 78. It's about 13 out of 78, which would be 1/6, which is 16%, 16 2/3%, about 17%. Okay. So this is a little less than 16% longer than the shorter cut, and so it's about 15% longer than the shorter cut. So the answer here is E. By picking smart numbers, organizing them in a chart, and estimating when the numbers don't work perfectly. Okay. So I just wanted to show that, because I think this kind of problem shows up a lot. Picking smart numbers is helpful. Organizing in a table or chart is a really helpful tool to have in your kit. Okay. So just think about this stuff, everybody. When you're reviewing a question, go through these strategies and see where they apply. They apply in almost every question. And again, usually there's the chance to do more than one. And I've never really specified that to myself. I almost always, when I teach a problem, it almost ends up like, okay, here's one way and here's another way, when really there's often multiple skills occurring at once. And so you want to practice seeing where those skills can be used and applied. I will stick around now for any miscellaneous questions y'all have. Otherwise, check out our upcoming courses at this link here, manhattanprep.com/gmat/classes. Remember that the first class of any course is free to try. So sign up for a trial session. I actually have one starting here in the next few weeks, so look that up. Hope to see some of you there. Otherwise, best of luck in your GMAT prep. If you're watching on YouTube, thanks for joining us. Please, if you have questions, comment. We answer in the comment sections. Happy to help in any way we can. We do these every 2 weeks or so, so look forward to the next one, and I will see you all soon. Until then, be well and good luck studying.